Alright, so it's currently exam season for me, and I've got a physics exam, well, literally tomorrow. I've got a physics exam tomorrow, and instead of studying for it, I decided why not try and make a video on some basic concepts in physics. So in this case, I'm going to be going over these three concepts regarding electrical circuits, and hopefully I can explain these concepts decently well. This topic is introduced pretty early on when you're learning physics, but it's also one of the harder topics to understand, in my opinion. Anyway, let's first talk about current. I think current is the easiest to define out of the three, and current is just defined to be the rate at which charge flows. And so then, well, what's charge? Charge is the basic physical property of matter that causes it to experience a force when kept in an electric field. And it's kind of like how most of matter has mass. And mass is another basic property of matter. But in this case, charge is the property that causes matter to experience a force in an electric field. And so from our first definition of what current is, we can say that current is equal to charge divided by time. And if we substitute some units into this equation, we can say that 1 ampere, which is what we measure current in, is equal to 1 coulomb of charge divided by 1 second. I should probably also mention though that when we're referring to charge in electrical circuits, we're usually thinking of electrons in this case. But don't get it mixed up that electrons and charge are the same thing, because they're not. Electrons are the thing that carry charge. That's why whenever you see something mention charge carriers, they're usually referring to electrons in electrical circuits. Anyway, let's talk about resistance. And resistance is measured with this weird Greek symbol, which is called ohms. And usually when you see a resistor in a circuit, you'll either see this weird zigzag line, or you'll see a long rectangle. So if we imagine a circuit with a battery and a resistor, the electrons that are passing through the resistor are going to be slowed down, and that decreases the current. So that's basically what resistance is. Resistance is just the thing that slows down electrons when they're flowing through a circuit. And I like to think of it kind of like a slope. So if we imagine a resistor here compared to a smooth hill, then an electron will have a harder time rolling down the hill of the resistor than if it were to roll down a smoother hill. And that's also why I prefer this symbol for a resistor compared to this one. Anyway, let's talk about voltage. Voltage is also called potential difference, and potential difference is just the energy per unit charge to move that charge from one location to another. If we put this into an equation, we can say that voltage is equal to the energy divided by the charge. Putting units into this equation, we can say that 1 volt, which is what we measure voltage in, is equal to 1 joule divided by 1 coulomb of charge. And we can also see from our definition of potential difference that potential difference is the thing that is causing our electrons to actually flow through the circuit. So if we didn't have any voltage, then we also wouldn't have any current. Lastly, I want to talk about Ohm's law. And Ohm's law just states that the voltage is equal to the current multiplied by the resistance. And if you're wondering where Ohm's law comes from, well, there's actually not a real derivation of Ohm's law. I'm oversimplifying it, but basically some scientists realized that when you divide the voltage by the current for some materials, you get a constant value, and they decided to name that constant value resistance. So that's basically how they got Ohm's law. Hopefully you understood at least something from the video, and I'm gonna go back to studying for my physics exam.